Hello everybody, welcome back. Today we are now going into chapter 6 of our textbook, and here is what we're going to be learning today. The lesson is going to be on something called indirect proof. So it's basically a new way of writing a proof, but we're still using statement and reason. So let me explain how that works, because this is something that is going to be very effective and useful from here on out. So here it is, indirect proof. So first, the idea behind an indirect proof is the following. Let's say that you have a statement, basically something that you want to prove, and I'm going to go ahead and write it out in a form that is, related to the logic that we have been using. So let's say that we have A implies B. So if we have a whole bunch of if statement, and I want to prove that it's B, the then statement is going to be your conclusion then. What I'm going to do for an indirect proof is I'm going to assume the negation of what I am trying to prove. So that is to say, if you're trying to prove, for example, that something is equal to 5, then I'm going to assume that it's not equal to 5. Kind of strange, right? But then what's going to happen is when you do this assumption, what will happen is when you write the proof, there will be a contradiction. And it's going to contradict something that you have either proved before in the theorem, or maybe a postulate that you know, or maybe some sort of definition. And I can't spell definition for some reason, so that is kind of strange. So hopefully you can kind of forgive me there. So let's go ahead and look at some examples as to what or how this an indirect proof actually works. So here it is. Here's the first example. Prove the theorem 4.3 or 4-3 using indirect proof. And for those of you guys that don't remember 4-3 because you don't remember what it says or by the name, it says the following. If you have two angles that are complementary to each other, then they are both acute. So just to restate it so then that way we can set up the proof, here's what we have then. Given that angle A and angle B are complement to each other, I want to prove that angle A and angle B are going to be acute. So then according to my indirect proof, what we're going to do is we're going to go ahead and assume that A and B are not acute. Okay, so meaning, once again, we're going to assume the negation of what we're trying to prove. Well, let's get an idea as to how that's going to work out here. According to what we've learned, if something is not acute, then there are only three choices. It's either the angle is going to be acute, obtuse, or it's a right angle. So that is my three choices. So that's kind of like saying it's trichotomy because it has to fall into one of those three choices. Now, thinking about the numerical measurement of the angle, since it's either a right angle or something that's obtuse, then that means that the measurement of angle A is going to be somewhere between 90 degrees and all the way to 180 degrees, inclusive of 90 because of the right angle, exclusive of 180 because we never look at the straight angle situation. Then, if I look at the other angle, it's going to be the same thing. The measurement of angle B is also going to be ranging between 90 to 180 degrees. Now, if you're wondering at this point, well, where can we go from here, or what can we possibly get out of it, and how does it actually contradict? Well, that's where we have to kind of go back to the well and think about what is it that we're trying to prove or indirectly contradict. I want to show that the two angles are complement to each other. So that means I'm looking at the sum of those two angles. Well, then that means why don't I go ahead and solve for the sum according to my equation over here, or my inequality. If I'm looking for the measurement of angle A plus the measurement of angle B, according to my inequality right here, by addition, then that means the lowest number that you can get is 180 degrees, and whereas the largest number that you can possibly get is going to be 360. That's kind of like my upper bound, and 180 is my lower bound. And right there, I think that's going to be our contradiction, because if you go by the definition of complement, the measurement of angle A plus the measurement of angle B is supposed to be equal to 90 degrees. And there we go. That's going to be our contradiction and therefore our indirect proof. So let's see how that actually looks like in the statement and reason. So first, like I said, what I'm going to do is I am going to assume that A and B are not acute to each other. So my reason for that is just indirect proof, because that's what I'm going to tell the author that I'm using. Then we said that as a result, if it's not acute, then that means that A and B are supposed to be right angles or obtuse. And we said earlier that is because of trichotomy. Basically, what I'm going to do is I'm going to go as far as I can using my assumption. And then once I get exhausted, meaning like there's nothing left I can tap or exert from it, then we go ahead and use other information. So then afterward, part 3, we say that A is then between 90 and 180, inclusive of 90, exclusive of 180. And also B is going to be the same thing. So that's kind of like going by my definition of a right angle and also obtuse. I kind of maybe skipped a few steps in between, but hopefully you can forgive me for that. So hopefully you can understand what is happening over here. Next, afterwards, like we said, what I want to do now is I want to add the two angles together, because remember, we're looking at complementary to each other. We need to add those two angles to each other. So then 180 is less than or equal to A plus B is less than 360, and that's by the addition property of inequality, because we're looking at inequalities in this case. A little bit tricky there, right? Well, now that that is going to be where we are at, I think that's where we're exhausted in terms of information that I can extract. So step 4 is kind of like a dead end. Now we got to go back to the well and see if it contradicts anything. And yes, it does, because from step 5, we're going to go ahead and use the given and say that A and B are complementary to each other. And from there, now we can say that the sum of those two angles are equal to 90 degrees, because the definition of complementary. And right there, that is going to be my problem, because if you notice that if we look at step 3 and look at step 6, oh, sorry, not step 3 and step 6, step 4 and step 6, right here and right here, you'll see that they're saying two different things. One is saying that it has to be equal to 90, the sum of two. The other is saying that the sum has to be between 180 and 360. So then that means that by contradiction, because step 4 contradicts step 6, A and B are going to be acute. So as soon as you see two or more steps that are contradicting each other, then that means that's the end of the proof, because you already showed by contradiction why it's not going to be able to work. This is the idea behind the indirect proof is like pigeonholing. We're basically kind of like saying the pigeon has to specifically go into this hole and it can't go into any other hole. And if it does, it wouldn't make any sense then. Okay. All right. So let's look at another example, and then that should do it for the section. This time it says prove theorem 4.4 by indirect proof. And once again, writing out theorem 4.4, here's what it says. Any two right angles are congruent to each other. Well, I think this one's going to be a little bit easier than the last one. As a restate, given is that you have the two angles and they are supposed to be right angles. What I want to do is I want to prove that angle A is going to be congruent to angle B, or show that they're equal to each other. Either one of those will be okay. But more importantly, because we're using indirect proof, right? Then that means that we're going to go ahead and start by doing the assumption or assume the negation of what I'm trying to prove. Once again, if you're at that point where you're thinking to yourself, hey, I think I can write this proof, by all means, pause the video and go ahead and try for yourself. If not, then let's go ahead and write it. Assume that angle A is not congruent to angle B. Okay, so that's going to be our introduction to the indirect proof. And then from there, we can probably extract from it the following. Basically, every single time that I'm doing these proofs right now, I'm writing out an outline before I actually write the actual proof. So then that way you can see how the flow of all of this works. So if the two angles are not congruent to each other, then that means that measurement of angle A does not equal to the measurement of angle B. From there, I think I've exhausted all the way that I can go with A is not congruent to B. So now let's go ahead and go to the given and see what I can pull from it. Well, A and B are supposed to be right angles. So from this, we can go ahead and say that the measurement of angle A is equal to 90, and also the measurement of angle B is equal to 90. And by transitive property, then we can go ahead and say that the measurement of angle A is equal to the measurement of angle B. And right there, you can see now there's your contradiction, because this step right here is contradicting this step right here. All right, so there's your proof. Let's go ahead and see the actual proof then. So first, like we said, first we're going to go ahead and assume that the two angles are not congruent to each other. And then that's going to be my indirect proof start. Next, we're going to go ahead and extract information from there and say that their measurements are not equal to each other. That's the definition of congruence. Once that is done, once we have exhausted the information that we can get from there, we now go back to the very beginning at the given, and let's go ahead and see what we can get out of it. Angle A and angle B are right angles, so that's given. Then measurement of angle A is equal to 90, just like measurement of angle B is equal to 90 because of definition of right angle. And from there, step 5, we can say that A and B are going to be equal to each other, their measurements, because of the transitive property. And right there, just like in the previous problem, hopefully you guys can see it, step 2 is then going to contradict step 5 because they're saying two things that cannot happen. So because of that contradiction, then now I can say that because of that, measurement of angle A itself cannot be congruent to angle B because of indirect proof or contradiction. All right, thank you so much.